Hello and welcome back to Mr. Latham's revision sessions for AQA Science. So today's session we're looking at P2.3, which involves work done, energy and momentum. So start off with, we need to understand the term work done. So work done is actually an energy transfer, and what we say is when a force makes an object move, then work has been done to the object. So due to the fact that work done is an energy transfer, the units for work done are the same as that for an energy transfer. In other words, the units are in joules. And the equation for work done is quite simply work done equals force applied multiplied by distance moved. And as with the other formulae that you have, or the majority of the formulae that you have for P2, this is a formula that you'll have on your formula sheet, so therefore you do not need to remember it. However, you do need to remember the units for work done, force applied and distance, which you can see below. So work done's units are in joules, force applied is measured in newtons, and distance moved is measured in meters. And you do need to make sure when you are attempting questions involving work done that the units are correct before you attempt to calculate your answer. So if you have a look at a quick question, a woman pushes a box a distance of 5 meters across the ground with a force of 26 newtons. What is the work done to the box? So we have a look. Our equation is work done equals force multiplied by distance. Force is 26 newtons and our distance is 5 meters. Therefore, to calculate the work done, we simply multiply 26 by 5, which gives us an answer of 130. Now make sure you include your units. As I said before, the units for work done is in joules due to the fact that it is an energy transfer. Therefore our answer is 130 joules. Now it is worthwhile mentioning when calculating, or should I say when using the formulae in physics, quite often it is possible to place the force, distance, work done, the factors that we have here, into a formula triangle, which is what I've placed here. So how do you work out which one goes in which place, so which occupies each place, is quite simply by looking at the formulae and looking at the relationship between the two factors, the two variables that we have here. So as you can see, the force applied and distance moved are both multiplied by each other. Therefore, they occupy the two bottom spots on the formula triangle. So force and distance are at the bottom, and they are multiplied, as we can see from the formula that they give us, and therefore the work done occupies the top spot. These formulae triangles are quite useful, as they enable us to rearrange equations very quickly. All we simply need to do is put our finger over the factor that we want to calculate, and then as we do so, it will tell us what we need to do with the other two variables in order to calculate the unknown. So for example, if I just put my cursor over D, you can see to calculate the distance moved, it would be work done divided by force. Equally, if I wanted to calculate the force, it would be work done divided by distance. So as I said, these formula triangles are very useful as they enable us to be able to calculate unknowns without having to actually be able to rearrange the equation. Now it is worthwhile mentioning that we can't do this for all of the equations, and you will see that shortly. A good example of that is kinetic energy, where actually you do need to be able to actually rearrange the equation as you're not able to use a formula triangle. So let's look at some examples of work done. So a very common question with regards to work done talks about work done to overcome friction. So when we have work done to overcome friction, the energy is transferred, and more specifically the energy is transferred as heat. And I've just put two examples on the slide to show you the types of question that they may ask you. So we have here, why do meteorites burn up as they enter our atmosphere? And why do car brake discs heat up when the car is braking? So our first one is, why do meteorites burn up? And it's because as the meteorites try and enter our atmosphere, there is work done to the meteorites to overcome the frictional force, and this causes the kinetic energy of the meteorite to be converted into thermal energy, which thus causes them to burn up. Equally with brake car discs, the car brake discs even, as the brake discs are applied to the brake pads are applied to the brake disc, there is work done to the brake pads and discs to overcome the force of friction, and this causes a decrease in kinetic energy and an increase in thermal energy. In other words, the kinetic energy of the vehicle is converted into heat energy, which causes the brake pads and discs to heat up. Okay, so our next bit talks about gravitational energy, or more specifically, gravitational potential energy. Now, gravitational potential energy is the energy stored in an object due to its position in Earth's gravitational field. So, as an object is raised off the ground, we have an increase in gravitational potential energy, which is defined as EP. E represents energy and the P represents potential. Equally, if an object is being lowered, so if something is moving closer to the ground, then its EP, its gravitational potential energy, will decrease. So this would be represented as a negative number. And how do we calculate the gravitational potential energy? Well, it is simply actually just work done. So it is force multiplied by distance, because again, work done is an energy transfer. So it is simply force multiplied by distance. However, on your formula sheet, they will give it to you in a slightly different format. They will give you the formula as gravitational potential energy equals mass multiplied by gravitational field strength multiplied by the height. Now, those of you who have listened to the previous videos, you will know that force, the force of weight, is actually measured by multiplying the mass of the object by its gravitational field strength. So actually, by multiplying the mass and the gravitational field strength, we are actually calculating the weight force. And height is just a distance in a vertical direction. Therefore, these two equations are actually the same thing, so to speak. So in your exam, they will give it to you in this format. However, in essence, what the formula actually is it is simply a work done equation that's just been dissected further. So a little question on the board is, can two objects of the same mass be lifted to the same height and have different gravitational potential energies? Now, before we can answer that question, we need to have a look at the factors that we have. So start off with, we have mass, and the question says that the mass is the same, and we said that the height is the same. Can they have different gravitational potential energies? And the answer is yes, they can, although to do so they would have to be lifted on different planets. The reason being is because the gravitational potential energy is defined as the mass multiplied by the gravitational field strength multiplied by the height. So if the mass and the height are the same, then the only way that the gravitational potential energy could be different is if the gravitational field strength is different. Now, it is worthwhile noting that the units, the value and the units, in fact, for the gravitational field strength is not something that you will need to remember. The gravitational field strength on Earth is 10 newtons per kilogram, and that is something that they will give you in the exam question. So it is just a number that they will give you and you need to put into your equation. It is not a number that you need to remember. Okay then, so let's look at an example for gravitational potential energy. So here we have a diagram which represents two people inside an elevator. And the question says that an elevator with two people has a combined mass of 1,280 kilograms. And the first part of the question is, the elevator moves from the ground floor to floor 3. Calculate the change in gravitational potential energy. So, lift doors close, the lift moves up all the way to the 3rd floor. So what is the change in gravitational potential energy? So firstly, we'll need to look at the mass, and the mass is given in the question. So the mass here is 1,280. We then need to multiply this by the gravitational field strength, which we already know is 10. And then finally we need to multiply it by the height that the elevator has risen. And from the ground floor up to floor 3, we can see it is 4 meters plus 3 meters plus 3 meters. Therefore, the lift has risen by 10 meters. So to calculate our gravitational potential energy, we have 1,280, which is the mass, multiplied by the gravitational field strength, which, as I said before, they will give you in the exam. You do not need to remember that number. And multiply that by the height that the lift has risen, which in this case is 10. And so our answer is 128,000 joules. Now that's quite a large number, so quite often in an exam they may ask you to give your answer in either kilojoules or megajoules. And kilojoules, there are 1,000 kilojoules in, so there are 1,000 joules in a kilojoule. Therefore, if we were to represent our answer in kilojoules, it would simply be 128 kilojoules. So we have divided our answer by 1,000. So our second part is the elevator then goes down to floor 1. Calculate the change in gravitational potential energy. So the two people in the elevator are moving from floor 3 all the way down to floor 1. So, what is the change in gravitational potential energy? So let's have a look. They're moving from floor 3 down to floor 1. Therefore, the distance they have travelled is 6 meters. 3 meters from floor 3 to floor 2, and then 3 meters from floor 2 to floor 1. The weight, or should I say, sorry, the mass of the elevator hasn't changed because nobody has got out. Therefore, we still have 1,280. The gravitational field strength hasn't changed either, so it would simply be 1,280 multiplied by 10 multiplied by our new change in distance or height, which is 6. And if we put that into our calculator, our answer gives us 76,800 joules. Once again, it's quite a large number, so if we represented that in kilojoules, our answer would be 76,800. In kilojoules, 76.8 kilojoules. So I have just divided 76,800 by 1,000 to give the answer in kilojoules, which just looks a little bit neater than representing it in joules. Okay then, so power. So power is something that you've looked at in P1, so this should be just a little bit of a recap. And the equation for power, again, is given on your formula sheet. And power is represented as energy divided by time. Now I haven't put this on the slide, but I can tell you that the units for power are in watts. Energy is represented in joules, and the time is represented in seconds. And it is very important that you have the correct units, just with any other physics formula, before you try and attempt to answer it. So our question says the elevator that we talked about in the last question takes 32 seconds to reach floor 3 from the ground floor. What is the power of the elevator? So what's the power of the motor that's driving the elevator? So if we have a look back, our GPE, our gravitational potential energy for the first part of the question, was 128,000 joules. And then we have our time taken, which in the question tells us it is 32 seconds. So our answer is 128,000 joules divided by 32, which gives us 4,000 watts. And 4,000 watts, just like with joules, you can convert that to kilowatts. There are 1,000 watts in a kilowatt. Therefore, the power of the motor that was driving the elevator is 4 kilowatts. Okay, so that was a relatively straightforward, just putting the figures into the calculator based on the format that they gave us the formula of energy divided by time taken. And as long as the units are there and the units are correct, so we have joules for energy and time is in seconds, then our answer is pretty straightforward to calculate. If the units are not correct, for example, if they gave us the time in minutes, then we would need to calculate the time in seconds first before we then attempted to answer the question. Okay, so our next stop looks at kinetic energy. So what is kinetic energy? Well, kinetic energy is simply the energy of a moving object. So the energy in an object that is moving. And it is calculated by the formula EK, E representing energy, K meaning kinetic. So kinetic energy equals a half, or 0.5, mass multiplied by the velocity squared. Okay, now this is one of the few formulae, as I mentioned before, that you are not able to put into a formula triangle, and you will see that actually the rearranging of it can be a little bit tricky, and I'll show you that on the next slide or two. So let's just look at some simple questions to start off with. So a cruise missile with a mass of 1,520 kilograms is shot towards a target travelling at 240 meters per second. What is the kinetic energy of this missile? So let's have a look at our equation. So we have half, 0.5, multiplied by our mass, which is 1,520, multiplied by our velocity squared, which was 240. Now it is worthwhile noting that that is 240 squared and not 240 multiplied by 2. Very, very different answers there, so make sure you do look at squaring 240 and not multiplying it by 2. So if we put that into our calculator, we have 0.5 multiplied by 1,520, our mass, multiplied by 240 meters per second squared. We have to square that number, very important. If we put that into our calculator, our answer gives us 43,776,000 joules, which is a very, very large number. Therefore, we would most likely convert that into either kilojoules or probably even megajoules. Now, megajoules is there are a million joules in 1 megajoule. So the answer for the question there in megajoules would be 43.776 megajoules. Okay, if we were to represent kilojoules, then it would be 43,776 kilojoules, but it makes more sense to probably represent this answer in megajoules. Okay, let's look at our next question then. So a bullet shot from a rifle with a mass of 12 grams travels through the air at 185 meters per second. What is the kinetic energy of the bullet? So hopefully, as you're reading the question, you have identified that the units for mass aren't correct. They have given us the mass of a bullet in grams, so our first job is to convert that into kilograms before we do anything else. And there are 1,000 grams in a kilogram, so we need to divide 12 by 1,000, which gives us 0.012, and then we are happy to then carry on and calculate our kinetic energy. So let's look back at our formula. We have a half, or 0.5, multiplied by our mass, which is 0.012, multiplied by our velocity squared, which is 185 squared. So if you put that into our calculator, it gives us 205.35 joules. Now, it's probably not worthwhile converting that into kilojoules, simply because it's not even 1 kilojoule. It would be 0.2 kilojoules. So we would most likely be leaving our answer there actually in joules. Okay then, so this is where it gets a little bit trickier then. So actually rearranging kinetic energy, and as I said before, we can't put this into a formula triangle, so it is a little bit tricky because you do need to be able to rearrange equations for you to be able to calculate these answers. So we start off with a kingfisher diving towards the water at a velocity of 6.2 meters per second to catch a fish. As the kingfisher moves, it has 0.6 joules of kinetic energy. What is the mass of the bird? So if we look at our equation first, EK equals a half mass multiplied by velocity squared. You can see that for this we want to calculate the mass. So we firstly need to rearrange this equation. So I'll take this as slow as I can, moving things over one at a time so you can see hopefully how I can rearrange this to make mass the subject of this formula. So, start off with, what I'm going to do is take velocity over, or should I say velocity squared over. As you can see on this side, it is multiplied by velocity squared. So to get rid of that, I'm going to divide both sides by velocity squared. And if I do so, it gives me kinetic energy divided by velocity squared equals a half multiplied by mass, which almost gives me the answer that I need, but not quite, because I still have a half of the mass. So to get rid of this, what I then need to do is multiply both sides by 2. So to get rid of a half, if you double it, it equals 1. So therefore we will get rid of the half on the right. So if we double both sides, or we multiply both sides by 2, then it gives us 2 multiplied by kinetic energy divided by v squared equals the mass. So if we then put the values in, so we have 2 multiplied by our kinetic energy, which tells us in the question is 0.6, and then we divide that by our velocity squared, which is 6.2 squared, and that should give us our mass. And the answer is 0.03121 kilograms. The units are in kilograms, but as you can see, our answer is very small. So in the exam, they may well ask you to give your answer in grams. So to do so, you will need to multiply your answer by 1,000, because there are 1,000 grams in a kilogram. And if we do so, our answer gives us 31.2 grams. So now we're going to look at the most difficult of all of the kinetic energy calculations, which is a calculation that involves us being able to calculate the actual velocity of an object, in this case a baseball. So if the question says a baseball with a mass of 145 grams is hit by the batsman and has a kinetic energy of 140 joules, what is the velocity of the baseball? Give our answer to the nearest whole number. So first thing I'm going to do before I even think about attempting to answer the question is having a look at our units. So you can see that the mass of the ball is given in grams. So the first thing I will need to do is convert that. And so I'll divide 145 by 1,000, which gives me 0.145 kilograms. And then let's have a look at the energy. The energy is in joules, so actually I don't need to convert that. So let's have a look at our kinetic energy equation. So kinetic energy equals 0.5 multiplied by mass multiplied by velocity squared. So I need to make velocity the subject of the formula. So what I'm going to do first is divide both sides of this equation by 0.5 and mass. So I'm going to take them both over, and you can see that we have kinetic energy divided by 0.5 multiplied by mass gives us the velocity squared. Then what we need to do is we need to get rid of the squared. Now how do you get rid of the squared? Well, you need to square root both sides of the equation. And when we do so, that is what it gives us. So kinetic energy divided by 0.5 multiplied by mass, square root of all of that gives us the velocity. So if we put in our values that we have from the question, our kinetic energy is 140 divided by a half, or 0.5, multiplied by our mass in kilograms, which is 0.145. So the square root of all of this gives us 43.9435, and the number keeps going. So what I'm going to do now is have a look at the back to the question, and the question tells us that we need to give our answer to the nearest whole number. So having a look at this, the nearest whole number there, 43.9. The 9 rounds up the 3 to a 4, therefore to the nearest whole number we have 44. Now don't forget, you need to include your units, and the question is asking us for the velocity of the baseball, therefore our answer will be in meters per second. So our answer is 44 meters per second. Thank you for listening.